Alright, here we go. Section 6.2, chord properties. We define chord in section 1.7 at the very beginning of the unit. Now we're going to talk about some chord properties. The first one is a conjecture, the chord central angles conjecture. And it states if two chords in a circle are congruent, then they determine two central angles that are congruent. In the diagram, we have two chords that are congruent. BA is congruent to BC. Since we know those chords are congruent, we now can conclude that their corresponding central angles are congruent. Next is the definition of inscribed angle. It's an angle that has its vertex on the circle and its sides as chords. In the picture here, we have three different inscribed angles. We have inscribed angle ABC, where vertex B is on the circle. We have inscribed angle BCD, where vertex C is on the circle. And we have inscribed angle CDE, where vertex D is on the circle. And all the sides of these angles are chords of the circle. Next we have the chord arcs conjecture. If two chords in a circle are congruent, then their intercepted arcs are congruent. In the picture, we have two congruent chords of this circle. You can see them designated with the double tick marks. The picture is also showing that their corresponding central angles are congruent, which is what we learned in the first conjecture. And what this conjecture is saying that since those two chords are congruent, we can conclude that their intercepted arcs are congruent. So if I name that point A, point B, point C, and point D, I now can conclude that arc AB is congruent to arc CD. Next, we have the perpendicular to a chord conjecture. It states that the perpendicular from the center of a circle to a chord is the bisector of the chord. So we can see in the picture here, we have the construction marks for the perpendiculars. Since we know that those are perpendiculars that go through the center of the circle, we now can conclude that they bisect the chords. Next we have chord distance to center conjecture. And it states that two congruent chords in a circle are equidistant from the center of the circle. So in this case, we're being told that the two chords are congruent. Therefore, we can conclude that their distance to the center is the same. And our last one, perpendicular bisector of a chord conjecture. States that the perpendicular bisector of a chord passes through the center of the circle. So in this picture, we have two chords, and we've drawn in the perpendicular bisector of each chord, and you can see the point where they intersect is the center of the circle. One way to construct the center of a circle is to do exactly what you see here and use this conjecture. Construct perpendicular bisectors of two chords. And of course, since the center lies on the perpendicular bisector of the chords, wherever they intersect will be the center of the circle.